So good morning dear cadets. Today I am going to teach you the oxides of 15th group. So hydrides of 15th group I taught. Now just see how many questions are possible in hydrides of 15th group. So many questions are not. Like that in oxides also so many questions would be there. And this unit is like that. Right now you are in the 15th group. Same process will be on. Continued in 16 group and 17 group. And 18 group is also there. Of course, the number of questions are less in 18th group, but questions are there. So, guard your girdle for such type of questions. There is one correction, dear cadets. Just see in the video of 18th August, AUG, 18th August, chemistry video only, exactly at 6 minutes, okay? Exactly at 6 minutes, I committed one error. What is that one? Just see. When I was explaining you electronegativity, so what I told, down the group electronegativity decreases due to increase in atomic size. Okay. So exactly at 6 minutes, I explained due to increase in atomic size. That is correct. But while writing, rather than writing increase, I wrote decrease. So in place of decrease word, you just insert the increase. Rest everything is okay. Okay. Once again I am telling you, in the video of 18th August, chemistry video, exactly at 6 minutes, while explaining the electronegativity, down the group electronegativity decreases due to increase in size and increase in screening effect. Okay. So I was uttering same word due to increase in atomic size, but while writing I wrote decrease in atomic size. So where decrease word is there, put increase. Rest everything is okay. Okay. You can't say that that is lack of knowledge. That is manual mistake. Okay. Because we have to think so many things at the time of teaching. That was the reason. It's okay. So I hope that you can correct it. Now let us move to the oxides of 15th group. See in the 15th group how many members are there? Nitrogen, phosphorus, arsenic, antimony and bismuth. So here I wrote except nitrogen, all other members form oxide in +3 and +5 oxidation state. Nitrogen can form oxides from +1 oxidation state to +5 oxidation state. Okay. So just see, nitrogen only will form oxides from +1 oxidation state to +5 oxidation state. Rest they will form only two types of oxides. Either they will form oxide in +3 oxidation state or they will form oxide in +5 oxidation state. So for rest member, the oxides are limited. For nitrogen, 5 type of oxides are there. What are those oxides? Just see the oxides of nitrogen. N2O, NO, N2O3, N2O4 or NO2. Okay. N2O4 is the dimer of NO2 and N2O5. Okay. So total how many types of oxides are there? As far as nitrogen is concerned, 5 types of oxide. What is their oxidation state? Nitrous oxide +1, nitric oxide +2, dinitrogen trioxide +3, dinitrogen tetroxide +4, dinitrogen pentaoxide +5. Okay. So these are the name. Now just try to understand. In place of N2O4 you can write NO2 also. What is the name of this one? Its name is nitrogen dioxide. Oxidation state of nitrogen is +4 only. Once again I am telling, N2O4 is the dimer of NO2. Okay. Now try to understand here. N2O and NO are neutral oxides. Rest all oxides are acidic in nature. I am talking of nitrogen only. The first two oxide, nitrous oxide and nitric oxide, they are the neutral oxide. Rest all are acidic oxide, means N2O3, N2O4, N2O5, they are acidic oxides. Okay. Agree with me? Now try to understand. Let us recall the last year knowledge of periodic table. all metallic oxides are basic in nature except oxides of aluminium, Al2O3, zinc oxide, PbO, SnO, okay, they are amphoteric oxide. What is this one? Amphoteric oxide, okay, amphoteric oxides. So what is the here question? All metallic oxides are basic in nature except Al2O3, ZnO, PbO, SnO. These are amphoteric oxide. Similarly, all non-metallic oxides are acidic in nature except 3 oxides. All non-metallic oxides are acidic in nature except 3 oxides. What are those oxides? 3 non-metallic oxides are neutral in nature. So 2 from the nitrogen only, N2O, NO and CO, okay. So only 3 non-metallic oxides are neutral in nature: carbon monoxide, nitrous oxide and nitric oxide. These 3 are the neutral oxides, okay. So as far as the oxides of nitrogen is concerned, now I told you. Now let us move to the oxides of phosphorus, arsenic, antimony and bismuth. First we should have idea. So already I told you only nitrogen will form so many number of oxide. Rest all members they will form only 2 types of oxide. That is first one in +3 oxidation state, second one in +5 oxidation state. But we should have idea that what are the name of those oxides. So dear cadets, now oxides of phosphorus, okay. So already I told you except nitrogen all will form only 2 types of oxides. So phosphorus 2 oxides are P2O3 or P4O6. So P4O6 is the dimer of P2O3. This is known as phosphorus trioxide. Oxidation state is +3. P2O5 or P4O10. So P4O10 is the dimer. Dimer means 2. Di means 2. Just you multiply this one with 2 and this one you 2. So you will get this one. Okay. So dimer form is more stable than. Why will they go for dimerization? They will go for the dimerization so that they can get the stability. So this is phosphorus pentaoxide. Oxidation state is +5. Okay. Now oxides of arsenic. Arsenic will form oxides in 2 oxidation state. That is arsenic trioxide and arsenic pentaoxide. Arsenic trioxide +3, arsenic pentaoxide +5. Now oxides of antimony. Now Sb2O3 and Sb2O5 +3 and +5 oxidation state. Oxides of bismuth, Bi2O3 and Bi2O5. So +3 and +5. +3 and +5. This is bismuth trioxide, this is bismuth pentaoxide, okay. So these are the introduction of different types of oxides of 15th group, that is starting from nitrogen to bismuth, okay. Now if we can say here I have summarized, these are the oxides of 15th group in +3 oxidation state and +5 oxidation state. So in +3 oxidation state, N2O3, P2O3, As2O3, Sb2O3 and Bi2O3. In +5 oxidation state, N2O5, P2O5, As2O5, Sb2O5 and Bi2O5. Okay. So just see N2O3 and P2O3. This is acidic. Similarly, N2O5, P2O5 they are acidic. As2O3, Sb2O3 both are amphoteric. What are they? Amphoteric. Bi2O3 and this one Bi2O5, this is weakly basic. So what is our generalization? What is our observation? Down the group, what is there? Down the group in the oxides of 15th group, basic character increases, acidic character decreases. Can we say or not? Just see. By seeing this one very easily we can observe that N2O5 and P2O3 is acidic. Similarly, N2O5 and P2O5 is acidic. AS2O3, Sb2O3, AS2O5 and Sb2O5, they are amphoteric. But Bi2O3 and Bi2O5, they are weakly basic. So what is the meaning of this one? Down the group, in the oxides of 15th group, basic character increases while acidic character decreases. So their explanation I have given this side. Just see here. Down the group, oxides acidic nature decreases while basic nature increases due to number 1, increase in atomic size. Down the group, what is happening? Atomic size is increasing. Okay. Now electronegativity decreases, and moreover to this, metallic character increases or not. So just see, when metallic character increases, so already I told you metallic oxides are basic in nature, non-metallic oxides are acidic in nature. This is the only reason that down the group atomic size increases, electronegativity decreases and metallic character increases. Hence oxides basic character will increase, basic nature will increase and acidic nature will decrease. Understood or not? Just try to understand. The acidic and basic nature of any compounds determined on the basis of oxidation state of central atom. Okay, oxidation state of central atom. In a nutshell, already I told you that metallic oxides are basic in nature and non-metallic oxides are acidic in nature. Some exceptions are there. Those exceptions I told you. Okay. So now there is one more factor which determines the acidic and basic nature of these oxides. That is, when these oxides react with the water, what kind of acid is formed. Just now I will explain that factor also. So remember, the acidic nature of oxides determined on the basis of their reaction with water and what kind of acid is formed after the reaction with the water. That will determine their acidic nature. I will explain you the acidic order strength of nitrogen and the rest members of oxides of this group. Dear cadets, before explaining the acidic oxides order strength, it is better to discuss these two questions and afterwards I will explain you the order of acidic strength for trioxide and pentaoxides of 15th group. Just see, some questions are there. If you see carefully, the oxides, number of oxides of nitrogen is more. Why? As compared to other members. So the number of oxides of nitrogen are more than that of other members. Why? So just see. Nitrogen with oxygen can form p-pi bonding. Very simple answer is there. Just see. Nitrogen bonding orbital is 2p. Oxygen also bonding orbital is 2p only. So energy gap is not there. So both bonding orbitals effectively overlap with each other and they form p-pi bonding. That is why in the oxides, means the number of oxides of nitrogen is more. Okay. In all the oxide, right from N2O2, N2O5, between nitrogen and oxygen, p-pi bonding is possible. And there is no need to explain the p-pi because already I taught you what is the meaning of p-pi. So that is why nitrogen number of oxides are more. Okay. And why nitrogen can form p-pi bonding? Two reasons. Number one, their size is small and electronegativity is high. That is why very easily it can form. Try to understand nitrogen and oxygen, their compounds is known as oxides of nitrogen. Am I correct or not? So nitrogen and oxygen both are having small size. Very effective overlapping would be there. So the bond which is formed between the oxides of nitrogen, they are strong. And a strong bond, if compound is having, that is stable. Okay. And if it is stable, so then their number will also be more. Am I correct or not? Means their bond is robust. If bond is robust, they are stable. Hence their number is more. okay, they will not disintegrate, they will not degenerate in the nature. So that is why their number is more. What about rest member? In rest member case, what is there? Their size is large, electronegativity is less. So they are not capable of making the p-pi bonding. So what they will form? They will form p-pi-d-pi bonding. And p-pi-d-pi bonding requires more amount of energy from the nature to make the bond, and that much energy is not available. Anyhow, they are managing for some oxides, but large number they will not form. This is the reason, that is why the oxides of phosphorus, antimony, bismuth, arsenic, their number is less, and nitrogen, plenty of oxide is known. So this is the reason. Next, one more question is there. Oxide of nitrogen form simple structure, while oxides of other members form cage-like structure. Cage means pijada. I hope that you are understanding. Cage means what is there, where you are keeping the parrot or some other animals, okay, pet animal, that is known as cage. So the oxides of nitrogen form simple structure, simple. But oxides of other members, they form cage-like structure, cage, okay. Just see, I will tell you here only the structure of P4O10. Just see, P, here O, here O, here P, here P, and here O. Just see, just try to understand. How many P is here? How many P is here? 4. Here how many P you have noted down? 1, 2, 3. 1, 2, 3. So make one more oxygen. Here one more oxygen, and here write P. Okay. So 1, 2, 3, 4 P is there. Now between 2 P put one oxygen. Between this one and this one also put one oxygen. Am I correct or not? It is like that. This bond. So try to understand here. Now here P double bond O, P double bond O, P double bond O, P double bond O. Now count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 oxygen, 1, 2, 3, 4 phosphorus. So this structure is cage-like or not? Cage-like structure. While the oxides of nitrogen, very simple structure. Just see, take any oxides. Suppose I am taking N2O5. So what is there? N single bond N, double bond O, double bond O, double bond O, double bond O, and between these two nitrogen, one oxygen. So simple structure is there. Please make one coordinate bond here, okay? One quad, otherwise it would be the violation of octet rule. So this is the simple structure of nitrogen. What about the structure of the phosphorus oxides? As for phosphorus pentaoxide, cage-like structure. So what is the reason? Try to understand. Very simple reason is there. Nitrogen can form simple structure because it is capable of making the p-pi bonding. So effective overlapping would be there, resulting into the simple structure. In case of other members oxides, they have to go for the p-pi-d-pi bonding. So what is there? For the formation of p-pi-d-pi bonding, p orbital electrons should jump to the d orbital. Okay. So the more amount of energy is required, because electron has to jump from p orbital to d orbital. Okay. So the number one requirement is more energy. Second one is there, they have to overlap, p orbital has to overlap with d orbital. So there is a complex structure. Okay. Because here a similar kind of orbital overlapping is not there. Like in case of nitrogen oxides, between nitrogen and oxygen, and rest case what is there? The p of oxygen and D of means phosphorus, arsenic, antimony or bismuth. That is why they form the cage-like structure. Okay. So this is also over. Now order of acidic strength. Just see. So dear cadets, just see here the acidic order strength of oxides of nitrogen. So just see, nitrogen is having how many types of oxide? 5 types of oxides. N2O5, N2O4, N2O3, NO and N2O. So last two NO and 2 are neutral. I wrote here. So this is the acidic order strength, means the highest in N2O5 and the least in N2O3. So explanation should also be there or not? Very simple explanation is there. Greater the oxidation state of nitrogen in their oxide, greater will be the acidic strength. Okay, are you getting? So out of 3, N2O5, N2O4 and N2O3, where the oxidation state of nitrogen is the highest? In N2O5, it is +5. So greater the oxidation state of nitrogen in their oxide, greater will be the acidic strength of that oxide. So in N2O5, acidic order strength is highest because the oxidation state of nitrogen is +5. This is one factor. Another important aspect is the acidic order strength of oxides of nitrogen is determined on the basis of acid they form when they react with water. Okay, so just try to understand. Just see, N2O5, it react with water, H2O, and it form HNO3. Similarly, when N2O4 react with H2O, what does it form? It will form HNO2 plus HNO3. Make this one 2. Yes, it is balance. Now here also 4 and 5, 3 to 5. It is also balance. N2O3 plus H2O. It will form HNO2. Okay, what is the name of this one? Nitric acid. Nitric acid. And this nitric acid is a strong acid. What is this one? Strong acid. What about this one? HNO2. This is nitrous acid. What is this one? Nitrous acid. And this nitrous acid is weak acid. Okay, so what I told you? I told you the acidic strength of oxides of nitrogen is judged on the basis of acid they form when they react with water. So since N2O5 react with water and it form nitric acid, which is a strong acid, that is why N2O5 is the stronger acidic oxides. Now N2O3 that form only nitrous acid, HNO2, that is weak acid. What is this one? Weak acid. That is why N2O3 is a weak oxides of nitrogen. N2O4 form both. N2O form both. And means HNO2 also, HNO3 also. That is why this is placed in between N2O3 and N2O5. Weak also it is forming, strong also it is forming. If you want to know the reaction between N2O5 and means different types of oxide with the water, it is very easy. Just try to understand. What is the structure of this one? Nitrogen pentaoxide and double bond O, coordinate bond O, double bond O, coordinate bond O, and their reaction with water. Water can be written HOH. Now just see, you do one thing, break the bond from here and give one H here and another OH here. Okay, so just see what will form here. Here just see, HNOOO, HNO3, here also HNOO3. So directly we can write here 2HNO3, 2HNO3, correct or not? Like that other will also react. Just see, N2O4 and double bond O, coordinate bond O, double bond O, coordinate bond O. Their reaction with HOH. So just try to understand here. See, give one H this side H. So this is HNO2. Okay. And give another OH, H this side, OH this side. So this is HNO3. That is why it form HNO2 plus HNO3. What about N2O3? N2O3 means N double bond, coordinate bond O, and one double bond this side. Their reaction with water HOH. Okay, so break from here. Give one OH this side, HNO2 and H this side. Okay, so what is the product here? Just see. OHNO2, HNO2, correct or not? So the two molecules of HNO2, that is nitrous acid. In this way also you can remember. Here you can write 2. Okay, so everything is balanced. Remember these reactions are very essential. So that is why this is the order, means acidic order strength of oxides of nitrogen. So in nutshell what we can say, the greater the oxidation state of nitrogen in their respective oxide, greater will be the acidic strength of that oxides, because their acidic strength is judged on the basis of acid they form when they react with water. Since N2O5 react with the water and form nitric acid, which is the strong acid, that is why N2O5 is considered to be the stronger acidic oxides. So greater the oxidation state of nitrogen, greater will be the acidic strength. Just you remember this word only. What about the acidic order strength of trioxide? So trioxides of 15th group is, this is N2O3 or P2O3, or you can write P4O6, dimer also. AS2O3 or AS4O6, SB2O3 or SBO46 and Bi2O3. This is the acidic order strength. Reason? Just see. In N2O3 central atom is nitrogen. In P2O3 P. Subsequently for other oxides also. So just see, nitrogen is the first member. Their atomic size is small, electronegativity is more. So small atomic size and high electronegativity contribute towards their acidic nature. That is why the oxides of nitrogen is strong in their tri-oxidation state. This is the order. What about in pentaoxide? Acidic order strength of pentaoxides. Same reason. Just see, among the pentaoxide, N2O5, P4O10, AS4O10, SBO4O10 and Bi2O5. So just see, nitrogen oxide is only the highly acidic. Reason? Same thing. Among all pentaoxides, nitrogen is what? Small in size, high electronegativity. That is why what is there? Very easily it will form the acid as compared to others. Same is the reason here also. As compared to other trioxide, this will form easily acid. So just see, in case of nitrogen oxide, what kind of acid they are forming. Okay, that is the base for determining their acidic order strength. And here what is the base? How easily they are forming the acids. Okay, other will also form, but as compared to nitrogen, they will form little bit late. So here for these two things, how easily they are forming the acids. Not only how easily they are forming the acid, afterwards we will compare the acidic order strength of those acids which they are formed when they react with the water. Okay, so just see, N2O5 will react with the water and it will form HNO3. Similarly, this will react and it will form phosphoric acid. Just if you are interested, so very easily we can just see here. Just a minute. See, P2O3 react with water and form H3PO3. Okay. Similarly, P2O5. Check the reaction is balanced or not. Write down here 2. Write down here 3. So 3, 6. 3 to the 6. Balance. P2O5 react with the water and form H3PO4. What is this one? This is phosphorus acid. Phosphorus acid. And what does it form? It forms phosphoric acid. What does it form? Phosphoric acid. Okay. As plus 3 oxidation state, plus 5 oxidation state. So just see, this is now we will compare these acids acidic strength with the nitrogen oxides when they react with water and form nitric acid. So this will be compared with HNO3, okay, and this will be compared with HNO2, okay. So just try to understand, this is stronger than this one, okay. So in the pentaoxide, what is there? This is the order. Please remember the reaction of these oxide with the water, because phosphorus oxo acids are there in the syllabus, and these phosphorus acid and phosphoric acid, they will they will have a lot of importance, because their structure is there, so many things are there, even these reactions are also there. So just you remember, when N2O5 react with the water, what is the acid form? Nitric acid. When N2O4 react with the water, two types of acid is formed, HNO2 and HNO3. When N2O3 react with the water, only one type of acid is formed, that is HNO2, nitrous acid. Similarly, when P2O3 react with the water, phosphorus acid is formed. When P2O5 react with the water, phosphoric acid is formed, H3PO4 and here H3PO3. So these reactions are very, very important, and remember and note down this order also. So here also, in case of acidic order strength of pentaoxide, same reason is there. Due to small size and high electronegativity, these oxides of nitrogen N2O5 very easily react with the water and form acids. They will also react with the water and form acids, but their rate of formation of water is less. Not only this one, whatever acid they are forming, their acidic strength is less than that of the acid formed by the nitrogen pentaoxides. That is why this is the acidic order strength. In this way, the oxides of nitrogen is completely completed, okay. Tomorrow I will teach you the halides of 15th group, trihalides and pentahalides. Thank you.